In game theory, fictitious play is a learning rule first introduced by G.W.Brown. In it, each player presumes that the opponents are playing stationary strategies. At each round, each player thus best responds to the empirical frequency of play of their opponent. Such a method is of course adequate if the opponent indeed uses a stationary strategy, while it is flawed if the opponent's strategy is non-stationary. The opponent's strategy may, for example, be conditioned on the fictitious player's last move. History. Brown first introduced fictitious play as an explanation for Nash equilibrium play. He imagined that a player would simulate play of a game in their mind and update their future play based on this simulation, hence the name, fictitious play. In terms of current use, the name is a bit of a misnomer, since each play of the game actually occurs. The play is not exactly fictitious. Convergence properties. In fictitious play, strict Nash equilibria are absorbing states. That is, if at any time period all the players play a Nash equilibrium, then they will do so for all subsequent rounds. In addition, if fictitious play converges to any distribution, those probabilities correspond to a Nash equilibrium of the underlying game. Therefore, the interesting question is, under what circumstances does fictitious play converge? The process will converge for a two-person game if both players have only a finite number of strategies and the game is zero-sum. The game is solvable by iterated elimination of strictly dominated strategies. The game is a potential game. The game has generic payoffs and is 2xn. Fictitious play does not always converge, however. Shapley proved that in the game, pictured here, if the players start by choosing, the play will cycle indefinitely. Terminology. Berger states that, what modern game theorists describe as fictitious play, is not the learning process that George W. Brown defined in his 1951 paper. Brown's original version differs in a subtle detail, and points out that modern usage involves the players updating their beliefs simultaneously. Berger goes on to say that Brown clearly states that the players update alternatingly. Berger then uses Brown's original form to present a simple and intuitive proof of convergence in the case of non-degenerate ordinal potential games. The term fictitious had earlier been given another meaning in game theory. Von Neumann and Morgenstern, 1944, defined a fictitious player as a player with only one strategy, added to an n-player game to turn it into a n+1 player zero-sum game.